I'm Dr. Mike Eef, and my talk was about pushing the limits of additive friction stir deposition to over 100 pounds an hour. In the current state of additive friction stir deposition, the deposition rates are about 20 to 30 pounds an hour in aluminum. What we did is we designed a custom machine with the OEM meld to explore the limitations of the process by pushing essentially to higher feed rates and higher forces. From there, we also investigated the energy usage, and we found that we use about 20% of the energy compared to traditional casting and forging. We can print at higher rates compared to any other additive technology at much, much lower cost and energy usage. The reason we're doing this research is the casting and forging supply chain in the US is an absolute mess. It takes 12 to 24 months to get forgings right now. And if you have an initial quality issue, you're going to wait another 12 to 24 months for a replacement. There's absolutely no flexibility in the supply chain. Additionally, there's no way to ramp up that supply. You would have to build $100 million+ plants, forging plants, to do the same thing that I'm doing with a couple $1 million machine. So the whole idea here is if we can print forgings on demand near the point of use, the point of need, whether it's your aerospace facility, your defense manufacturer, maybe it's a semiconductor part. Who knows? If you use big aluminum parts, or even aluminum, copper, titanium, this is a great technology for that. The problem we're trying to solve is how do we get our manufacturing onshored and get it closer to the point of need so we're not shipping around thousands of, 1,000-pound parts. Space as well. So common misconceptions would be that we don't melt. What's cool about the solid state welding, and in this case, solid state additive manufacturing, is we get the material hot, but we turn it into like a Play-Doh. And then we smush that Play-Doh layer by layer over itself to form big, heavy parts. Or maybe, if you already have a big, heavy part, we just repair it or add features to it, where other technologies don't do well with that, because when aluminum melts, bad things happen, cracking, poor properties, etc. So we do get hot, but we do not melt in additive friction stir deposition. Follow me on LinkedIn. I'm relatively active, want to be more. My email is meff@ewi.org, or just go to ewi.org and fill out an inquiry and we'll get back to you.